I'm Pet Dugas. In this screencast, we're going to look at geometric sequences in series, where terms in a series are multiplied by a common ratio to get the next term. To find any term in a geometric sequence, you use a formula that's listed here. The nth term, a sub n, of a geometric sequence is going to be equal to the first term times the common ratio, r, raised to the n minus 1 power. So in other words, you take that first term, you multiply by the common ratio n minus 1 times. This is very similar to the arithmetic sequence a sub n, a sub 1 plus the common difference times n minus 1. So that's an arithmetic. So hopefully you can see the parallels there. Let's use that to find a particular term in a geometric sequence. So to find the sixth term in a geometric sequence, where the first term, a sub 1, is minus 3, and the common ratio is minus 2, we're going to use that formula. The nth term is equal to the first term times the common ratio multiplied by itself n minus 1 times. Well, in this case, n is equal to 6 because we're looking at the sixth term. The common ratio is negative 2. The first term is negative 3. So we're going to put those into the formula. Negative 3 is our first term. It's multiplied by negative 2, n minus 1, in this case 6 minus 1 times. So that's going to be negative 3 times negative 2 to the 5th, which is negative 3. So this is a sub 6. Negative 3 times 2 to the 5th is 32. So this would be negative 32, because a negative raised to an odd power is going to be a negative. So it's going to be negative 32 times negative 3, or positive 96. That's a sub 6. Now let's use that formula to actually generate an equation for any term in the sequence. So for example, let's write an equation for the geometric sequence 5, 10, 20, 40. So our formula, a sub n equals the first term times r to the n minus 1. Well, a sub n is going to be any term. A sub 1 in our situation here is 5. Common ratio we can find by dividing any two consecutive terms. So for example, 10 divided by 5 is equal to 2. 20 divided by 2 is equal to also 2. So our common ratio r equals 2. So we're going to replace r in the formula with 2, and it's to the n minus 1 power. And indeed, that's the formula. A to the n equals 5 times 2 to the n minus 1. Now it becomes a little bit more complicated when we don't know the first term. Here we have a sequence where a sub 5 is 4 and the common ratio is 3. We've got to kind of go back and figure that out. A sub n equals a sub 1 times r to the n minus 1. Well, we know that the fifth term is equal to 4. So a sub 5, which is 4, is equal to a sub 1, which we don't know, times the common ratio of 3 raised to the n, in this case, 5 minus 1 power. So 4 equals a sub 1 times 3 to the 4th power. Well, 3 to the 4th power is 81. So 4 equals a sub 1 times 81. Divide both sides by 81. And we're going to get that 4 over 81 equals a sub 1. We can use that to put back into the original equation for any geometric sequence now that we know a sub 1. So any term in this particular sequence is equal to 4 over 81 times the common ratio of 3 raised to the n minus 1 power. To be able to find the sum of terms in a geometric sequence, of course, you can manually, numerically do it by listing all the terms and adding them together, but that becomes very difficult with large numbers of terms. Using a formula, you can find it quite rapidly. If you know the first term and the number of terms, then the sum is going to be equal to the first term minus the first term times r to the n over 1 minus r. If you know the first and the last terms only, one of the things you could do is go back and figure out r and then just put it back into the original formula. Or you could use this modified version of that formula where the sum is equal to a sub 1 minus a sub n times r divided by 1 minus r. So suppose Julian hears a song by a new band. He shares a link for the band's site to 5 of his friends, and they do the same thing. They each forward a link to 5 of their friends. So the link is forwarded again and again, following the same pattern. How many people will receive the link on the 6th round of sharing? So we know that each time they're multiplying by 5, the common ratio is 5. And we're talking about the 6th round, so n equals 6. And in the first round, he shares it with 5 people. So a sub 1, the number of people in the first round, is 5. So we're going to put this into our sum formula. The sum of the first n terms is equal to a sub 1 minus a sub 1 times r to the n over 1 minus r. So in this case, the sum of the first 6 terms, where n equals 6, is going to be a sub 1, which is 5, minus a sub 1 times r to the n, so 5 times 5 to the n, and in this case n is 6, over 1 minus r, which is 5. So it's going to be 5 minus 5 times 5 to the 6 over 1 minus 5. A lot of 5s in this one. So when we multiply all that out, the denominator is negative 4, and the numerator is going to be 5 minus 5 times 5 to the 6th, which is 5 to the 7th. And when you do this on your calculator, you get negative 78,120, and then we divide that by negative 4. So in the end, we get 19,530 people shared in total by the 6th round. So let's look at sigma notation, which I introduced in the last screencast. We're going to evaluate the sum of the geometric series that goes from terms 1 through 12, and the series is 3 times 2 to the n minus 1. So one method is to list all 12 terms and add them together. But a faster method is to use the sum formula. So the sum of the terms in a geometric series is going to be equal to a sub 1 minus a sub 1 times r to the n over 1 minus r. So in this case, we do have to figure out a sub 1. If we put in a 1 for n into this formula, we get 3 times 2 to the 1 minus 1, which is 2 to the 0, which is just 1. So a to the first is 3. So this becomes, and we know also that r equals 2 because the common ratio is the number that's being multiplied here. So this becomes a sub 1, which is 3, minus a sub 1, 3, times r to the n. And n in this case is going to be 12 because if we take 12 minus 1 and we add 1, there are 12 terms here. So it becomes 3 minus 3 times 2 to the 12th power over 1 minus 2. And so the sum of the first 12 terms, the sum of this sequence, is equal to 3 minus 3 times 2 to the 12th, which is equal to 12,285, all divided by 1 minus 2, 1 minus r, which is negative 1. So this becomes negative 12,282 over negative 1, or 12,282. So a much faster way than individually summing those 12 terms is to know and use the sum formula. So we've looked at geometric sequences in series in more depth, being able to find individual terms, being able to write rules, function form for those series, and also being able to find partial sums using formulas.